So do a short intro and then we switch. And okay. Let's do it.
Dobar dan svima, dobro jutro, hvala što ste došli. Ovdje sa nama su Jerži i Peter. Hvala dečki što ste došli iz Češke i zapravo i nas podržati, ali i naučiti naše drage korisnike što više možemo u ovih par sati o IDEA StatiCi i konkret i Steel. Naravno, svi ste dobro došli na druženje poslije od 4:30 nadalje. Neki ste se prijavili, neki niste, ja mislim, u Cultural Centru Cinema. I ja i dečki više volimo da je to obostrana komunikacija, da tu se razvije i neka rasprava, da pitate pitanja, tako da i nama je puno lakše predavati kada imamo dvosmjernu komunikaciju, nemojte se ustručavati. Oko 10:30 će doći neka kavica, pa onda i poslije, nakon što edukacija završi, između 12 i 1 imamo pauzu, u 1 počinje Upland Bridge. Dakle, u toj pauzi ćete isto moći s njima komunicirati, povući ih malo za kavu. Okay. Bolje da sad rikne nego poslije u 10:30. Ništa, da ne dužim, hvala što ste došli još jedanput i Jerži.
Thank you, man.
What is yours? Ako nešto oko engleskog nije razumljivo, tražit ćemo ga da ponovi, tako da samo naprijed. U nekom trenutku ću vam poslati papirić da se potpišete, da znamo ko je došao, evo, to ću vas samo zamoliti. Hvala.
Okay, thank you, Gianmarco. Good morning, everyone. Thank you for coming. My name is Pogledajte. I'm a channel manager at IDEA StatiCa, and I'm here with my colleague Petar Červinka, who is a product development engineer for Steel. As Gianmarco mentioned, we would like to tell you a little bit about both our steel and concrete applications. I will start with the concrete ones, a little brief introduction of what you can do, what are the use cases, how it can help you in your daily life, and then we'll move on to steel with Peter, where he will show the latest news in our latest release, plus some tips and tricks that could also help you with your daily life designing steel constructions. So just a little bit of intro, as you probably know, but just a quick recap. IDEA StatiCa is a Czech company. We are based in Brno. We have currently global presence, but with a local touch, with our local resellers such as Baldinistudio here in Croatia. We have BIM links with many other solutions on the market. And what I think is really important is that our software and our methods are validated by universities. We will talk about that a little bit later, but mainly ETH Zurich in Switzerland is helping us with the validations of the method to make sure our results are safe and help you stay on the safe side to deliver the best results you can. Alright, so talking about concrete applications, we have a couple. So I will start with Detail, which is, let's say, our flagship solution for concrete. It's like, I like to call it a little bit of a black horse. Like, you don't expect it to do much, but you can actually do quite a lot with it. So let me start first maybe with one really nice new thing, and that's the new user interface. As you can hopefully see right here, it may look quite familiar, which was not the case up until the latest version, because the UI was quite old and needed, a little bit of polishing. But now, as you can see, it's pretty much the same as you know it from Connection, from the steel applications. So it will look very familiar. It's quite fast, and yeah, it's just a powerhouse that can help you with your designs. So what does it do actually? The Detail is focused on D regions, so discontinuity regions. So for example, your typical use case could be some depth ends with an opening, or walls with windows or doors. Again, discontinuity regions that you can check and validate. What is behind and what we do differently is that we don't use your standard strut and tie model, but rather we use CSFM, which is compatible stress field method, again validated by universities, which is showing you the stress fields and how the concrete actually behaves, how the crack widths appear, and so on. So this is the difference and the basis of the detail as a product. You can do all your standard checks that you are used to, both ULS and SLS, so ultimate limit state as well as serviceability limit state. And this is quite important. So everything that you expect to check with the concrete to be on the safe side is there. And again, the method and the solution has been and is continuously validated by in cooperation with ETH Zurich, again, university in Switzerland. So you can be sure that it is on the safe side, definitely. All right, and a couple of use cases. As I mentioned, you can check depth ends, you can check pier caps, walls with openings, even pre-stressed beams, for example. So there are quite a lot of use cases, but this is just the beginning. We are actually working right now on 3D concrete. What I will talk about is in 2D, but we will add the missing dimension to move to 3D. Again, validated with ETH University in Zurich. And we will have some nice additional workflows that you can do. For example, in connection, you can check connection with anchoring, right? So in the future, you will be also able to connect this to detail application and check also the concrete block itself, the reinforcement, how it realistically behaves, which is something unique that, as far as we know, no one on the market is capable of doing right now. So this is really something that will help move us, and hopefully all of you, also to a brand new level in terms of concrete. All right, a couple of nice pictures and examples. Like I mentioned, the standard building, reinforced concrete, some doors, with some windows. Again, you can check how it realistically behaves and check that it's according to valid Eurocode. So that's one typical use case. You can also check prefabricated and pre-stressed beams, for example, for industrial buildings, such as factory halls and industrial projects in general. For those of you dealing perhaps with bridges, you can also check the bridges diaphragms, again with openings, checking the discontinuity regions, how it realistically behaves. So again, many use cases that you can cover with detail. So that's detail first application. You are also able to purchase it separately, due to the code in the United States, which doesn't allow the use of the other concrete applications I will talk about. All right, next up is RCS, reinforced concrete. This is, as the name suggests, you can check the 2D cut of your cross sections, typically I or T sections. It is based on Baumann theory, so again validated by the academic community. So again, staying on the safe side. There is also a really nice feature where you can also import the cross sections using DXF file, which is really nice. Or there is even cross-section editor, so you can like draw the cross-section, which may be in some non-standard, let's say, non-standard shape that is not standardized, so you can also do that. We have 4 codes and 9 national annexes. So again, we base the solution on valid Eurocode. So as you all know, the new Eurocode is coming in 2025. Again, with 3D concrete, this is something we are already preparing for, and again, helping you stay on the safe side and design your projects in a safe and optimal way. So that was RCS application, second application. Third one is beam, which can help you, again, as the name suggests, beam. So this is B region, right? Bernoulli regions. You can define the different sections of the finite element, how it behaves. What is also really nice, there is again link back to RCS, so you can take these different sections and again, based on your engineering, common sense and experience, you can tip off certain sections where you definitely want to check that you suspect might be critical, and you can export those to RCS and again check it in the 2D. So this is, I think, really nice that the applications are like linked back together, and you can check the same element in multiple again to have it double checked to make sure you are on the safe side. And last but not least is member, which is quite honestly not as commonly used, but it has its use cases definitely. This is for members that might be thin. And again, the difference between us and other solutions on the market is that typically the other solutions suspect the forces are acting right at the starting point, at the node, we might say. But we know that as the realization goes, right, the element, if on concrete is armed, is cast, it's already a little bit of the axis, right? So this is already something we account for, and again we can help you check these critical members using the member application. There is actually the GMNI, which is geometrically nonlinear analysis, right? That can help you check that. So again, unique solution for the concrete members. One last thing maybe to mention what is important for the concrete applications. We have many different BIM links to other FEA and CAD softwares. So here's a screenshot of our website. You can actually check it online. We are continuously adding new and new BIM links based on demand, and yeah, where we see it could have real impact. We are all up for it. So if there will be some possibly some solution it will be missing with the BIM link, we are open to adding it. Maybe two more things I would like to mention. We also have quite extensive support center, which is available on our website. So feel free to go there and check it. There are many knowledge-based articles, blog posts, case studies that I think might be useful for you because, yeah, again, as I mentioned, the benefit I believe is that we are a global company. So the issues you are dealing with, it's very probable that other engineers around the world are dealing with as well. So this is something that we can help you with. It's completely free, it's accessible for everyone, so feel free to use it to full extent. And one last thing from me is campus. Has anyone of you heard about our campus, or is it something completely new? Oh, okay, I don't see any nodding. Great, Marco. So we have actually campus courses. These courses are again completely free. The content is completely free, so you can go through it at your own pace. It's an e-learning platform. And at the end, if you are interested, there is a paid certificate which you can obtain, which is saying, okay, you know, this guy is certified to work with this application. He knows what he's doing. So there are actually two for concrete. One is for detail. One is currently for RCS. But we are already working on two additional more for pre-stressing. Pre-stressing again is probably the hardest topic, right? There is for concrete. So our colleague Tomáš Svoboda, our product development engineer for concrete, is currently working on those. So once they are ready, we will be happy to share with you so you can learn more about pre-stressing for concrete. All right, and that's a wrap for me. That's a short intro about the concrete applications, and I will pass the word to Peter.
Thank you.
Thank you so much.
Hello, welcome. It's a pleasure for us to be here. We want to tell you a lot of things, but we are there also to listen to you, so don't be hesitate. I will start with some theory, then I will show you some examples, tips and tricks. So if is anything unclear for you or you've got any question, don't be hesitate to ask me. So, IDEA StatiCa Steel applications. What are the roots? What are the bases? What we use? Years ago, engineers were intended to use component method, which is strongly recommended by Eurocode. You all know this method, and it's really great for the code-based joints. What is the problem? When there is something not so simple, not so straight, engineers are pushed to find another solutions. And therefore we come with our CBFM method, which is connection of component method and finite element method, that we are combine these two methods into one product. We are able to calculate internal forces and stress division in the connection by finite element method, but use the working curves of the components in the joints. That is the base, what we do in a very quick time. So the calculation is very quick, very easy, and also edit or combined with the code checks at the end. So it is easy to, it is easy to have the results which you want and which you require. If you are more interested, we've got these books about this method. Also in our website, as we already mentioned, there is plenty of information, so you can find more information, go into more deep issue with it and find all the needed information here. What are the main applications for steel? We've got application connections, which solves the problem of one specified detail in the connection. The standard workflow is that engineers create a global analysis model, then they've got internal forces in one node and want to design the connections in this node. And that's application connections. That's why we create this application. We are able to import any topology, any geometry with all the necessary data, such as cross-sections, materials, and so on, import it into our application, work with it, create the design. On the other hand, it is also possible to import the current design from 3D CAD, for example, advanced steel, into the connection application, use the design, and check for the current internal forces. Second applications, I will only touch today, but if you will be interested, we can spend there more time, is the application member. It's very similar to connections because we just use it for check of one critical member. Again, the workflow is, I've got my global analysis model in SIA, for example, and I want to check stability issue on one specific critical beam which I identify. So I am able to use this beam, go into application member, check the stability issues or some discontinuities such as openings, real stiffness of the connection, for example, variable high of the cross section, and continue. The third applications is not intended for checks, it's our checkbot, and it is something where all these importing links are happen. So I will show you later. You just go from SIA into our checkbot and you work with plenty of connections, plenty of members, work with them in one application and use it for checks of each connection separately. The third is the connection library. We've got two platforms. It is not so, or the first platform is in our desktop application. It is here for a long time. You are able to use our predefined templates from it, but users are also able to export and use their own libraries of the templates. So it could help to be faster in your work. When you've got some type of connections which is continuously used in the company, you are able to create this template and use it again and again, not to create it from the scratch. And the last, the viewer applications, it is mainly intended for designers, to export the information. It's cloud applications where anyone is able to open our IDEACon file. It will stop in a while, don't be afraid. Anyone is able to import the IDEACon file and check the geometry in 3D with all the information about bolts, about materials, and so on. What is our advantage? That even if we use this advanced method of the analysis, we also provide all the necessary checks required by the codes. Currently, we've got 8 national codes: Eurocode, ASI for US, code for Indian, Australia, and so on. So users are able not only analyze the connections, but also provide the report, which is really important. This is something what we want not only know about it, but prove the concept. And we've got several types of analysis. The most important one is stress-strain analysis. We just prove that your connection is available to transmit all the required loads. We are able to provide buckling analysis for some slender plates, webs, and so on, and others. Stiffness, fire analysis, seismic check, for example, fatigue, and so on. So now I want to show you very shortly what's new in IDEA StatiCa 23.1. As we already mentioned, we utilize the view of the applications. So right now, doesn't matter if you are in connection or detail. Both application seems really familiar, really same. So it can be easy to switch between the applications, or the workflow is stay. Don't be afraid. All buttons are new, but it stay in the same place with the same function. It is not something brand new. How I will work with the application. The work is still the same. Functions are still the same. Just the buttons are new. Second important thing, what we have in a list from many users is IFC export. We are now able to export into IFC, IdeaCon, or the detail of the connection. IFC can be then open in any free viewer, or it can be imported into your 3D CAD software, Advanced Steel Tekla, and use it as a reference. With all the, and the important thing, with all the necessary information in metadata. So you've got, again, this information about bolts, about materials, directly in the file. Well-designed improvement, what I see as very important for users is this value UTC. I will see it later. But what we have done is that we improve, or we totally change the method how we calculate it, because I think every one of you who are using our connection application knows this checks that everything is okay, but welds are on 99%. Ooh, why is it so? Yeah, but it is because there are two values, UT and UTC. UT value is the check of one weld element, but as the weld behavior is plastic, it's nonlinear, other elements are really under this number. And now we're providing this UTC number, which is really, or which is the realistic resistance of the whole weld. So right now, users are able to say my welds, resistance of my welds are on 80%. Next feature for safer design is the position of the force. As you know, I hope, we are able to provide function that not all the forces are acting at one place. Sometimes, for example, for these shear connections, it's really better to have the acting of the force in the bolts, because the hinges in the bolt now in the axis. You are able to move with the forces, and right now, this is the new feature, you are able to check where the zero moment of this acting force is. So it could help you to make safer your design. Detailing checks for bolts and welds. According to Eurocode, again, it is intended for the base users, for the beginners, or for the beginners, but can be also used by advanced users. What it is, there are some requirements by Eurocode, for example, for size of the weld. And before, users are needed to all check and then say hey, these requirements are not fulfilled. So right now you are able to see it in this table or in the brief results that the design, this construction requirements are not fulfilled. We improve this filler plate recognition. In the past, very often can happen that we did not find that it is filler plates, and we do not apply this safety factor according to Eurocode. Users then are pushed to create another type of check for bolts and so on. We really strongly improve this recognition, so right now it is safer, and the filler plates are implemented in this bolt checks. Fire resistance design, we improve these functions. Fire resistance was part of our checks for a longer time, but right now we are able to provide automatic calculated temperature according to fire curve, according to Eurocode, and also we provide the fire resistance for this detail. And yeah, slight touch to member application. I'm not sure if anyone is using it, so maybe we will start. Member application was intended for advanced user till now, because it is not only it was not only about the critical member, but it was very necessary also to create the boundary conditions by the reference related members. Right now, what we have done, there is this idle support, which thinks like a very rigid plate with the standard settings of the support. So that means that you are able to create simple beam in a very simple way, very quickly, but still with the advantage of the real stiffness of the connection. One more feature in member application is this construction stages or the strengthening. What we are able to do is that we divide the loads into two categories. The first one is the original load, and the second one is the new load. It is very useful for strengthening of the beams. When we at first calculate the original beam design with the original load, then user is able to define the strengthening on the beam. For example, here it is side welded T-profile on the bottom of the member, and then we calculate a whole model with the original stresses from original load plus these new stresses from the new load, which is, for example, increased. Yeah, and this is just a little thing for users. You know this function from connection application. Sometimes some weld is missing, bolt are missing, sometimes can happen this, and application is not able to calculate the model. Till now in member application there was just information singularity. What to do right now? Yeah. So we add this information, where is this singularity happening, so you easily find that it is in plate stiff F1. I go to stiff T1, see there is missing welds, add the welds and complete the calculation. So, and now I believe it will be more interesting. We'll see what happened. So, I will go out from the presentation, or stay there for a while. Okay. This is the standard code check of the connection according to Eurocode. I think you all know it. So this is my required detail, and I need to check bolts for tangent bolt, for shear, welds, some component of the end plate or the flange, and so on. Yeah? It is the hand-made calculation check of the connection. What is this? I believe we all know this. Every company has their Excel sheets which are prepared for specific connection type, and it's really easy to use. Just fill these fields about the cross section and so on, and have the check and result for this detail. What is the disadvantage of this solution? And I can prove it from my experience. Is that very often when company is bigger, or the man who created this Excel leave the company or is sick or something, and anyone other type something into this quotation in the Excel, it stopped to work. It is not anymore safe, and no one knows what to do with it. So what is very easy? Use IDEA connection for simple connection. Yeah. So I will switch off the application and show you.
Try to adjust the resolution.
Okay. Yeah. So just wait a minute, please. We try to solve this problem with slipping of the applications.
Which is okay. Then Beamer is not responding. Okay. I'll change in the meanwhile. You continue, we will change to our Beamer.
Yeah. Okay. So I got requirement for this simple connection. How simple I can do it in a connection application? I go into the wizard. Here I will find the required topology. So it is T, it's beam with this, and I will start with one of the templates which is here. There is a classic end plate. Here is classic end plate with extended bolts. So I will create the model. At the beginning, what I can do is to change material to my required, change the default bolts, and so on. Change the standard if I am not in the European Union or I want to do another check. Then I create a model. And here it is. What I want to do, it is not the same on the top but on the bottom. So here is the dimensions, and there is to profile symmetrical. So I just to switch it to profile, and I see that I'm almost done my work. Do you hear me good, or should I? Yeah. So now I just a little bit modify my connection to have it as I want, and use this stiffener on the top. So I will use one of our operation. I will use this widener. It is created here, but I want it only on the top, so I will go into here, and location is not both, but I believe here, yeah. And now I am able to modify the geometry of the plate. So at first I don't want it triangle, I want it chamfered, so switch this and create this edges for the welds, for example. Just change to 10 millimeters, this is too big for me. And then I will change the geometry. So the high, I believe, would be 60, and here it could be, for example, 100. And now I'm ready with the same connection, with the same design, and can calculate it. What will happen in this Excel or in this hand calculation? If something happened on the side, yeah? Someone require, for example, this hole. Very often in industry design, there are some pipes, some electricity, some operations, and so on. The same, there is missing stiffener. How should I do the design in my Excel sheet? So we are engineers, I find a solution, right? But if I want to be safe, quick, I will go into my detail. Just correct this one. I will go to my detail, and I am able to neglect the bottom stiffener, just like this. And again, by a new operation, add a hole into the web. I correct the position, correct the diameter, and I am here again. Calculate, Yeah.
Niko ne koristi laptop, jel? Ne treba struje.
Just tell me when you switch me off. So. What is important to say?
Okay.
Okay.
Yes. No.
No?
No. Where is the
Cool.
Yeah.
See you there.
This one. Switched off. No.
A znači,
Don't do this to me.
Important information, it is not part of IDEA application. Don't be afraid, it will not happen to you. Maybe we can talk a little. How many of you are the new users or not know? There you are. Other, do you know? How many of you are not our users? Are for the first time or just begin with the application? That's great. So don't be hesitate to ask. Sometimes I will show some tips and tricks. It could be more complicated, but don't be afraid. Don't be hesitate to ask. Yeah? Just I'm here for you, so I will describe what I want to say. What is important? There are these green flags, but no engineers want to just finding these green checks. It is not safe, yeah, finding the green. So what you can do here is go into check tab, and there you can find all the necessary checks in detail. For plates, there are also some information. For bolts, you can use this plus button, and when I make it bigger, I can check all the required checks according to Eurocode. So it is not a black box just with a red or green flag. You can you can find all the numbers, all the values, forces in bolts, used factors, and so on in this detail check. And all these detail checks are available in the report. So I will go to report. I'm able to customize it, how much detail it should be. More information or less information depends on me. Add some pictures, add some sections with dimensions from the model. Then I click on generate and create my report, which is required. There is some basic topology information about the cross sections, about the supports used in the model, about bolts, materials, loads, and also there are all the checks, welds, and there are bolts. I've got this without this detail quotations which we see before. I'm able to switch it off for the most critical one or for all. I will use the most critical one, just that the generation takes more time, so it will be quicker. Yeah, and you can see that the bolts and the detail checks of the most critical bolts are here. As I mentioned, there is this button IFC, so we can try how it works. Yeah. If I go to, it is here, yeah, right now. And when I open it, this is BIM Vision, but it really doesn't matter which viewer you have. You can see that there is the 3D view on my detail in IFC. When I click on bolts, I see all the necessary information in the metadata. I'm able to measure bolt distances and anything what I want. So yeah, I will show you something just here. So distance between bolts should be somewhere. Yeah, it depends on the viewer which you want to use. So back to presentation. And there is an example. Yeah. Example 2 with the BIM links. As I mentioned, we've got these links between the analyze model and IDEA applications, or between 3D CAD model and IDEA application. I've prepared this one with SCIA engineer. So if I go to SCIA, I've got this model prepared. It is some bus station somewhere. And right now, what I want to do is to check, for example, anchoring. So what is the workflow? I select the required node with all the members and go into add in. Yeah, you can find it here, or I think somewhere there it is also here. Steel connection, IDEA StatiCa. Not sure. I use all the time in SCIA these orders, so it's quick. Just wait a second to start the application checkbot. Yeah, it is starting. And right now there is creating an extra model next to your SCIA file with the same name and with the link into the SCIA. So it is not only one, or it is one direction link. But what I want to say, it is possible to update your design. When you change something in SCIA, just click update, and all the new informations are transmitted into the checkbot, and with all the changes of loads, cross sections, and so on. So now what I need to do is to choose my code which I want to use. So here it will be your code. Click on create project. And now I've got this empty checkbox. What is necessary to do is I want to say if I want to add connection or member. So for this case, I want to create a new connections. So I create on connections, and right now the software go back to SCIA, finding what is selected there and importing these members, load cases, and so on into the checkbot. We can see that there is this column and this bracing, which I selected in SCIA. If I want more connections here, I can also select more of them and import it in the same style as right now. And now I want to create design of this anchoring detail and check it. So I will choose the connection, there is only one, and go to open. What is good to say, you can see this, this symbol. We change it according to the status of the connection. Right now, me as the user, I can see that there is something to be modified. It is not okay, it is not failed, but I need to modify this connection. When it will be okay, you will see there will be green flag. But it is also possible that I will calculate it. I've got, for example, 10 connections here. I will calculate all of them, and some will be okay, some of them not. So I will have there some green flags and some red crosses. I will show you later. So right now I will open the connection and create this anchoring detail. So you can see that we are now in the connection application. The same application as you know, without chatbot, without this link, it is the same application opened. So it is really easy to create a design in one application, which you know. What I can do right now, I can create it by operations. So I will add this anchoring, choose the anchors. Yeah. Then I want to connect the bracing, so I will again create a new operation, go to here. I want to use this connecting plate, and now I can play with it a little. So I will choose the correct member, and here it is. What can I do, or how can I do it in better way? If I am solving very often this type of connection, I can have it in a connection library. So right now I think there is one defined by us. It is this predefined one, and it is this one. So I will apply the design. Application asks me what are my preferred bolts, what is my preferred concrete block material. I let it as it is, and just apply the template. And you can see there it works without any problems. Sometimes, I will show you later, there can be, because the template is modified according to the size of the cross section, so sometimes there can happen that there are some clashes or something, so you need to do more modifications, but here it works perfectly. And right now I'm able to calculate the detail. As I can see, with these many iterations and low ratio of the load applied, there could be some problem. Also, when
sorry, you have already inputted the characteristics of this concrete block. Are you checking the anchorage length of these blocks?
Yeah. And
where have you specified this concrete block?
Okay. So I will stop the calculation. We can see it go. It takes more time, and go into this operation base plate. Base plate operation create the. I was showing this way. Yeah. This is the original beams without any operations.
Yeah.
Now I am applying this base plate. And you can see that there is plenty of properties of this base plate. And here is the part which is for foundation block. So the size of the foundation block is modified here. I can choose the size of it, the depth and the offset, the size in the 2D and the depth of this foundation block. And if I want to change the length of the anchors, it is here in anchors, and there is anchoring length. So right now I have set it to 125 millimeters. If I want to use shorter one, for example, or longer one, I can modify it here. Also,
but it doesn't take account if this concrete block is correct or not, and if there is any reinforcement in this block.
Yeah, you are right. Right now, we are not providing this type of check. The foundation block is considered without this reinforcement or cracks and so on. What is in a plan to the future is our 3D concrete, which is not in our applications right now. The solution is ready, but as my colleague mentioned, we don't want to get away applications which are not verified. So for every method, every applications, we cooperate with universities. In this case, we cooperate with ETH Zurich, and they do the verification of our method. So right now, we've got colleague who is fully intended to work on these verifications in cooperation with this university. They do verifications against the experiments, and we see the differences between our solution and the result of the experiments. And on the second side, they compare it with some scientific, if I can say it, scientific software, for example, ANSYS. So they create the same model in ANSYS and again compare the results with us. And there are some criteria which has to be fulfilled for them to say, yeah, this solution is verified, you can use it. And in this moment, we are able to incorporate it, implement it into our application and provide it for our users. So, yeah.
Okay, thank you.
So you are finding bugs in ANSYS. That's good.
Yeah. Yeah. So I will. Yeah. What I want to show you here is that we've got something what we call the calculate load extremes. When I use it, you can see that it switches only one combination. It is because there are only 4, but it is a nice feature. Very often users are doing it in SEA, for example, that they are just use the combinations according to the Eurocode. And there is a plenty of combinations in SEA and plenty of combinations in checkboard and in the connection application. So the calculation takes a lot of time. And when you are creating your design and checking if it is okay or the plate should be thicker, wells should be bigger, you have to spend a lot of time on this iterational process. So for this, we recommend to use this calculation of load extremes. It is based on the properties of the cross sections in the beginning in this big black point 0, 0, 0. Yeah. So it is important to know that we are not able. It is not calculation. It is something what use like a pre-design or how to say it, because we are not consider the operations for this finding of the extreme loads. But for the iterational process, it is safe to use because you reduce your combinations which are used for the calculation. You prove that it is all okay, and for the final design, for final report, we recommend switch again all the combinations to on and calculate it to be on safe side that I have calculated all the combinations required from the global analysis. It is also possible to set here in settings load extremes some limits. Very often from, for example, from SEA or from these analysis softwares, there are a lot of very similar combinations, and the difference is in 0.1 in a torsional moment, for example. Yeah, some forces which are not here in real, but in a global analysis it is, and therefore there is a plenty of combination. So users are able to neglect it, these small forces which not should be there by this. So if I set there 1 kilonewton or shear less than 1 kilonewton will not be used for the calculation or the combination with this shear. So right now I can calculate it and check the design. I can see that it was faster. There is single, yeah, because of this. So I will now calculate.
I have one question.
Mm-hmm.
Is it possible to edit these beams that you import? These are like read-only. You cannot
in connection.
change the rotation or profile.
I will show you how to make it. Just let the calculation complete it. Or maybe we can spend this time by this question. There are two possible solutions how to do it. In the checkboard application, when you click on the member, you are able to change cross section, for example. So you are able to change against the VA. What is important to know when you click on sync with your VA, all these changes will be replaced by the VA design. So you lose your results or your details. So it is it could be used, but with this information. There are eccentricity in the checkbot, also in a member, not in the connection. Why is there? Because very often the global analysis model is created by access only. And for example, for floor structure, where there are different size of the members, there are users who use all on axis without a real top of steel level. But for designing of the connection, it is necessary to set it. So you are able to move with the eccentricity of the beam to the correct level and use it for a real connection. Yeah? And we'll see with this. It is not. It doesn't matter. It is because, now I say you the secret, it will not pass the requirement because the design is not good. What is necessary to do here is to enlarge concrete, make the anchoring gland bigger, and calculate it, and it will be okay, I think. The second possibility, what to do, back to this question, is to go to checkbot, and you are able to export the connection. You can, if there will be more of them, you are able to create one IdeaCon file with more project items, or create plenty of IdeaCon files. And when I export it, I'm again available with all these settings for members, angles, and so on.
So I always copy this connection that is created.
From the folder.
Yes.
Yeah, and it is not possible to change the properties, I think, right?
No, when you copy it, then you can change it.
Really? I will show you the wait a minute. Here. So we'll just look up. And when we check it, so I can go into this file. To use this, it is not safe. So here, this one is copied from the folder. When I open it, so this one is exported from checkbot. You can see that all necessary things is here, as you mentioned. I hope, yeah. And here is the one which is copied from the folder. And if I go to settings of the member, you can see that rotation is here, but the position is different. And that's the difference between just copied the file and export it. And we strongly recommend to export the file to have the full functionality of the connection. It is because if you imagine that there is beam, one connection here, one connection here, and you change the coordination or position of the member, of this member in this connection, you destroy this connection. So you go here, change it, destroy this, and still the same. So that's the reason why it is not supported to modify it directly in checkbot. But if you want to do it, export the file and modify it in this exported file. It is the best way how to do it.
applying the same working the joint from advanced steel, for example. When you calculate one joint and you make some modifications and apply sync, all the other joints use ports. You have to check it.
From advanced.
Am I doing something wrong?
Oh no, I don't think it is possible.
For example, if I have 5 calculated joints, and I change one to the sync.
All calculations are
all calculations are erased.
Yeah, I think there is right now there is not implemented that we are recognize which change which. So we just know that the user click on sync, so we cancel the results. But the design is still there, right? With forces which you said are there. So you are able to, I will show you in Checkbot. You are able to go directly to Checkbot and calculate it from calculate it from here. Now it is shaded because I'm working on this file. Oh, finally. There is something wrong, sorry. But when I save it, close, so I would be able to calculate it directly from Checkbot. So I do understand it is not, you lose your results, but don't be afraid. All data are there, and you are able, for faster work, calculate it directly from Checkbot. It is not necessary to open each connection, calculate it in an application.
It's necessary to recalculate.
Yeah, it's necessary to recalculate. And you can see that there is this mark for not okay.
Yes.
So, this way. We can continue with another connection. I want to check this roof one. So I again select the members, go to Checkbot, and click on connection. I will import next members with other forces.
Good for us, we forgot to.
So now I can really whisper and you will hear me. So, and I've got this second connection imported. So again, I will open it with connection application, and it is one of more complicated. So I will show you the workflow with the connection library, how to use it properly, and what can happen if the design is not fully okay. So again, I click on propose. Here is my template, so I will apply it to the design, choose the bolts, and I am already ready, but I see that the design doesn't seem quite good. It is because it is just a template. So I need to make some modification. For example, here, for the stiffening plate, I'm sure that I need to change the cooperation of the size of it. So I will change this X position, to modify it just like here. It seems quite good. Then I will go to this connection, and I see that there is a collision. I don't want to use it. So again, I go to operation connecting plate. I change the distance of the bolt or of this plate. So I will choose this X dimension and change it to 250. Now it seems okay, but I see some warning on the left corner. Plate clash warning. We have implemented some clash checks, which check if there are some plates which are in a clash with and also with the welds. So I can use two options how to find it. The first is that the name of the plate is here. It is also the name of the operation, which with little additional information. So I go to operation CPL4. I can see it here, and the operation is highlighted in the model. The second possibility is to use this transparent solid view, and I can see the collision marked by this red something. And now I can see that the problem is with this gusset plate and its corner. How to solve it? The simple way is use this editor. So I click on it and I can choose one of these three plates. There is a gusset plate, the lid, the tank, and the lid. So I want to modify the gusset, click on it, and I will open this plate editor. It is the geometry of the plate. What can I do is to click here on the drawing, and I can check the dimensions of the plate. Here I can see the distances of the hole and so on. So I will go back to 2D, and now I know that I want to cut this corner. So I will add the bevel, choose the proper corner, apply, and I see that the geometry is not very good for me. So I can use checking by hand, maybe, or I can draw it in AutoCAD, for example, or I can calculate the triangle. Better option is to delete this operation and use our new functionality, which is from 23, I think. I will show you what do I mean. I will add a new operation work plane. It is added into the general position in the connection. Till now, or till this version, it was possible to place it anywhere in the model and rotate it in both directions. Right now it is not necessary to find this correct position, but use this assigning to other plate or member. So I will choose assigning to plate, and I want to assign it to this capped plate. Again, I can go into this list and find the proper plate. But much faster is just to use this arrow, magic arrow in here, select the proper plate, and it is automatically selected from the list. So it can make your work faster. Plenty of operation has these arrows to choose the correct member or plate directly from 3D. And now when I've got this work plane in the middle plane of the lid, I'm able to move it by the required distance from the plate. So I know that the lid has 10 millimeters, the half is 5, required space there is 10 millimeters, so I will move this work plane by 50 millimeters. Here. And now I'm sure that the distance is the required 10 millimeters between the lid plate and the cut. And now I just add a new operation, plate of cut. Again, select by the arrow the plate which should be cutted, select the work plane from here, and I have the required geometry, and I'm sure that it is precise 10 millimeters without any assumptions and so on. Yeah, this was this example. What I just want to mention that we've got these BIM links also for 3D CAD, as you know. You got their advanced Steel, Tekla, other 3D softwares. So it is just to mention. Here you can see the BIM links which we are able to use in the checkbox. So now we can do some tips which will be quite shorter. The first tip. Oh, okay. Oh, okay. What I want to say, there is more possibilities how to modify the geometry of the connection detail. You can use these offsets, which are intended to move with the members, in the 3D. But be aware about it, because when you change the position of the member, you also move with the acting point of the loads, which is defined for this member. What it means, when I move with this beam, as you can see here, by 180 millimeters, there will be some additional moment which is done by this eccentricity to the beginning of the model. So here you can see that there is 9 kilonewton meters, which shouldn't be there. What it means in practice, you can see there are two identical details, geometrically identical, there is no difference. But what has happened? One of them has bolts to 95%, and second one has bolts only to 77%. How is it possible? I will show it in an application. Just close this, and open the proper one. This is the original model. Yeah? What I want to do is to somehow extend this beam into the farther face of the column and use the end plate from the bottom. So one possibility, what user did in this case, was to move it. So I can read that it is 240 high column, so I will move it by 120 millimeters. And I can check what was happened with internal forces. If I go to load cases and select the proper one, use the transparent mode, you can see the graph of the moment which is in this connection. In the original one, without this offset, you can see that the moment acting in the axis of the column is this 32 kilonewton meters. It is here. But when I move it by this 120 millimeters, the moment acting in the axis of the column is much bigger. It's the eccentricity multiplied by the value of the shear or of the shear force. When I then check the bolts for this moved beam, there is used a bigger bending moment. You can, you know it from a hand check. I've got the bending moment, distance of the bolts divided by this distance, and we got the forces in one force up, one force down, forces in the bolts. And I can check there, if I show the bolt forces, that there is a value of 86 kilonewton. This is not correct model. We were to use this offset functionality by this way. How to do it? I go back to my original one, neglect this offset, and use operation instead of the moving with the beams. So I go to operations, use the cut operation here, just select the proper beam, and right now it is cut on the closer face of the column. It is not difficult. In the cutting plate I can choose the farther, and you can see that the cut will use extend function and extend the beam into proper position. I can use some offset because of this end plate. And now when I will check my internal forces in this connection, you can see that, just a second to be clear. When I check internal forces, you can see that the 32 kilonewton meters is in the acting point, in the axis of the column, in the place where it should be, and the internal forces are in proper way for this design. In this, and this is the final design, I just add the end plate, some stiffeners calculated, and here I can see that instead of 86 kilonewton in the bolt, there is 69. Big difference. In this case, it was on the safer side because user used a bigger moment. So his design was safer with thicker plates, bigger bolts, but it could be used wrongly also on danger side. If I do the same mistake or same inappropriate steps, for example, for for case when I want to connect this beam by end plate into the column and use this distance like this, neglect the cut, and go into the internal forces, check my moment, I can see that acting moment 32 kilonewtons is in the phase, but correctly use bending moment for design of the bolts should be much bigger. Yeah, 32 is here, and there I can see there is increased moment. So this design would be on danger side. So be aware to use this offset. Where it is necessary to be used. And that's again model, and I will show it to you. Sorry for that. So from the beginning. So here and here. As I mentioned, there can be a model, for example, of the floor platform. And it really depends on engineer what style of modeling he use or she in a global analysis model. Some users use these offsets also in global analysis, so he's got all the beams top of steel in the same level. But sometimes they don't. And in these cases it is necessary, when I want to design properly this connection of the floor beam, to move it into the same level of top of steel. How can I do it? I can use these offsets, so I will find the proper number. One way is to calculate it. Yeah, here is EH300, there is different high model, so I want to calculate this distance. Or I can just choose it by hand, if I will be lucky, not still finding the number. It is not necessary to do it by this way. You've got functionality which can align one beam to another. In here, you can see align, and right now it is set as default in node. I can change it to member plate. So I easily choose here it is created already I will show you the workflow. I will choose the aligned plate, it is this one. I will choose the related plate, it is this one. And then you can see that the top of steel is in the same level of both of these beams. So for this design it is necessary to use it by this. Yeah. Here I just mention it to be aware about this. Third tip is about this model type settings. Very often, if we go back to, I will show it in the model. When I create one new, for example this one. So as default, beams are set to model type N, UI, UZ, and so on. That means that we don't consider any support on the opposite side of the beam. But for example, for the bracings, it is intended that users don't want to consider that there is any moment in bracing. Yeah? It is intended to transmit only actual force. Very often in importing models, there are some small shear forces in these beams. For example, here can be 0.1 and so on. When I check my internal forces on this beam. I can see that there is created small, but still there is some bending moment. For the software, that means that that there has to be some support against this bending in the model. But I don't want to, because there can be the bracing with 1 bolt, for example, and there is nothing, and the calculation will be interrupted. How can I prevent this behavior? Is just to change model type to these forces. And in this way, I say to software that don't consider bending moments for this member. We just add the support which will take these bending moments in the model. So very often it could be used for this type of bracings or shear connection, for example, for the beam intended only for shear. You don't want to have any bending moments for the bolts, for example. So this was the model type. For tip is using of DXF plate. What does it mean? Very often, I will just open the file and show it to you. Very often, it is necessary to have some special shape of the plate from few reasons. Yeah, there can be different requirements for that. What is the possibilities in our software? One is to use this plate editor and use chambers, bevels, arcs, holes, notches, and so on. Very often, if the geometry is really difficult, it is not possible to model it directly in the connection application. We are checking software, we are not modeling software. So one possibility is to create your design in Advanced Steel, import it into IDEA. But what if I want only a special shape of one plate? Yeah? I don't want to model whole model in Advanced Steel and import it. So for this reason, we provide for the plates a possibility to import the DXF file from AutoCAD. So you just prepare your shape in AutoCAD, any of them, and here in the shape, you just choose this polygon possibility. One, yeah, just out, you can easily define a circle. This is not this case, so I will use polygon, and here is button DXF. So I've got there my DXF file. I just open it, and it is opened in this editor. As you can see, my colleague played a little with this strange shape. I don't want to use it, I want some standard shape. So I will choose the lines which should be imported. I can do it by clicking in the scene or in this table. It is very faster. Define that it is outline. In case if there will be some opening, in the same way can be defined the opening. Here I can see the final shape of the plate. What is good to check is if the original model is in meters or millimeters, because it is depend what size you import. Then click on OK, and here I can see that it is not very good. Why is that? It is because the original file is in incorrect units. So right now I can go to AutoCAD, change the units. I've got one modified, so don't spend time on it. Here I believe it is that. You can see it's very fast to modify it. It's not this one, so hopefully this one. Again, not. Why? So in this case, I will go to AutoCAD and check what was happened. So I will check units. It is inches. So I will change millimeters. Okay. Check that it is okay. seems so. So save the file. It is needed to be saved at DXF, so I will choose DXF file, save it. Yes, I want to replace, and need to be closed for the import. And there is a gap. Should be this one.
Maybe it's time for coffee, huh?
Maybe.
Coffee is served, so.
Okay. So we will continue. We will find a way why it doesn't work.
I will, in the meantime, try something else.
Technique of the sheet, right?